Good morning. I hope everyone has shaken all the ice and from the expedition in the Antarctica yesterday. So, welcome to operator training simulators. So let me first I'll just introduce myself briefly, that I'm an analyst at ARC, and I've covered operator training simulators for quite some years. Before my work at ARC, I actually designed control systems, started them up, and trained the operators, right? And in many cases, helped to build training simulators. So it's a really good topic, a favorite topic of mine. One of the things I did want to talk about a little bit is, we heard this term digital twin throughout the conference quite a bit this week. And I've always been a big champion of the concept of digital twin. But digital twin, to me, was more about the twin part. The digital is kind of obvious, all right? Everything is communicated digitally. But if we think about models are a pretty important part of operator training simulators. So they are spatial models, CAD models, photo, lithography, point cloud, raster, vector files, and maybe even a clay model, all right? Then you have topological models that didn't care exactly about the spatial geometry, like a molecule with a carbon and hydrogen and oxygen in a certain order, or transmission grid, or distribution lines, or roads, or networks. And then, of course, on the operator training simulator, there's a process model of a flow sheet simulator that is a heat and material balance with specific models for pumps, distillation columns, reactors, and things. And then there's some other models like fluids, all right? Computational fluid dynamics, laminar, turbulent flow, and more models, all right? These are all digital twins, right? You have models of gambling, right? Monte Carlo, simulation, that's what it's called, right? And the other thing is, if you think about it, you learned almost everything you know from models, from dolls, armors, Tinker Toy, erector sets, all right? These are the models we've all used. Anyway, I just thought I would point out that there's a lot of twins in the digital twin world. So imagine the risk of untrained operators, right? Sometimes facilities have a hard time justifying this, all right? So these are pictures of some of these kids that, they're probably imminently trainable, all right? So I think that's Wilbur Wright, all right? And anybody know who the other guy is? So he was a brilliant physicist, Steve Hawking, all right? So these guys could have the potential to be trained, all right? Now, okay, you have the new millennials coming in, you have to train them, all right? And they have to operate kind of the equipment there on the left. Actually, I want to jump through this a little bit faster now. So one of the things about training is fidelity, So if you're going to train to fly a plane, you have to have kind of the right model of that plane. I guess I won't go into it too much, but there are a number of ways of calculating. It's very difficult to calculate how much operator training reduces the risk of a high consequence accident. First of all, if you ask anyone, what is the risk tomorrow you will have a high consequence accident? It'd be a pretty hard number to calculate. The second number is, how much is the cost of that high consequence accident, including all the lawsuits and things? You can't really calculate these numbers accurately. They're very hard. So there has to be some difficult ways of estimating that. In any event, I'm going to turn it over right to my panel.